Assalamualaikum warahmatullahi ta'ala wabarakatuh and salam sejahtera. I'm Dr. Ziana. In this video, we are going to cover chapter 1, Introduction to Database System. These are the objectives of this chapter, where you are going to learn the difference between data and information. What a database is, the various types of databases and why they are valuable assets for decision making. Alright, the importance of database design, the main components of database system, and the main functions of a database management system. Why we need databases? Actually, we need database because it able to solve many of the problems encountered in data management. Database used in almost all modern settings which involve in data management. For example, business, in research, and also in administration. Right? So it is very important for you to understand how databases work and interact with other applications. Alright? Next is data versus information. What is the difference between data and information? Basically, data is a raw facts, which is building blocks of information, and it is unprocessed information. For example, staff name, staff ID, sex, age, phone number, and etc. Information is a data processed to reveal meaning, and it becomes knowledge, which is the body of information and facts about a specific subject. So the accurate, relevant, and timely information is key to good decision making. And a good decision making is a key to survival in global environment. Right? For example, in this case, you have a good information, a good information about the staff, right? So after process the data, you can get information about the staff performance. It considered as knowledge about the staff. So based on this knowledge, management, for example, can decide to give 2 months salary or more to the staff after achieving a sales target. This is for example only, right? So from the raw data itself, combined with the information, which is we process the data, and then it comes to a good decision making, right? This diagram is the info engineering model of data, information, knowledge, and decision. It is start from data, which being processed to a meaningful information, right? And also a knowledge, processed to a knowledge. And based on the accurate and timely information, we can make a decision. This is another example that can illustrate how the data information will be processed to become a knowledge. For example, egg and baking powder is data, raw data. Process become a cake as an information. And it presented properly and become a proper cake. Proper presentation. And from the proper presentation, it become a good knowledge where based on the knowledge, people decide to eat the cake until it finish, right? To understand what drives a database design, you must understand the difference between data and information, right? So data is raw facts. Raw means not yet been processed to reveal their meaning. For example, suppose that you want to know what the users of computer lab think of its services. Typically, you would begin by surveying users to assess the computer lab's performance, right? So this screen basically shows the web survey form that enables user to respond your questions. Okay. Okay. From the survey form in the previous slide, when the form has been completed, okay, the form's raw data are saved to a data repository, right? Such as shows in this figure. Okay, this is raw data. If you look at this data, okay, although you now already have a data, right? But it is not useful with this format. Okay, if you read page after page of zeros and ones, it's not likely to provide much insight, right? Therefore, you have to transform this format, okay, raw data format, into a data summary, like the one, okay, data summary. Okay, I will show you in the next slide. Okay, this is the summary format, right? And it is much better than the previous slide, where you can read, okay, the percentage here, right? So this is how we transform raw data into a information. Okay. Okay, this is another example how you can transform raw data into information. Okay, by using a graphic, right? With the graphics capability, you can enhance your ability to quickly extract meaning from data, right? Okay, for introduction to a database, okay, we start with data management, which is a discipline that focuses on the proper generation, storage, and retrieval of data. Okay, next, database. It is a shared integrated computer structure and stores of a collection of end user data, which is raw facts of interest to end user, and metadata, which is data about data, which can provide description of data's characteristic and relationships in data, and also it can expand the value of data. Okay, so what is the role and advantages of database management system? Okay, DBMS. DBMS is a collection of programs which can manage, structure, and controls access to data. Okay, DBMS is an intermediary between the user and the database, which consists of database structure stored as file collection, which can only access files through the DBMS. Okay, DBMS enables data to be shared. Okay, and it also integrates many users' view of data, right? For example, okay, for this course, we are going to learn IBM DB2 as our database management system. Okay, you are going to learn this in your lab session. I think this Wednesday. Or other example is like Mongo database, MongoDB. Okay, and if you heard about the MySQL, they want also a database management system. Okay, okay, what is this figure all about? Okay, basically, DBMS serves as the intermediary. Okay, this one between users and database, right? So the database structure itself basically is stored as a collection of files. Okay, and the only way to access to the data in those files is through DBMS. Okay, so this figure basically emphasizes the point that this DBMS, okay, present to the end user, okay, with a single integrated view of data in the database, where DBMS receive an application request and translate them as a data to present to the user, right? Okay, these are the advantages of DBMS. Okay, which it can improve data sharing, meaning that DBMS will help create an environment in which end users have better access to more data and better manage data. Okay, the DBMS also improve data security by provides a framework for better enforcement of data privacy and security policy. Okay, better data integrations, meaning that a wider access to well-managed data promotes an integrated view of the organization's operation. Okay, DBMS can minimize data inconsistency. Okay, basically data inconsistency exists when different versions of the same data appear in different places. Okay, so the probability of data inconsistency is greatly reduced in a properly designed database, right? So DBMS also can improve data access, okay, by making it possible to produce quick answer to ad hoc queries. Okay, for example, from a database perspective, a query is a specific request issued to database management system for data manipulation. Okay, for example, you can read or update the data. Okay, okay, the BMS also can improve decision making, meaning that better managed data and improved data access can make it possible to generate better quality information. Okay. Next is increase end user productivity by combine with the tools and transform data into usable informations. It can empower end user to make a quick informed decision that can make the difference between success and failure to the economy. Okay. Okay, databases can be classified according to number of users, database location, type of data stored, the intended data usage, and the degree of which the data is structured. Okay, these are the types of databases. Okay, the number of users determines whether the database is classified as single user, desktop, or multi-user. Okay, single user support only one user at a time, right? So desktop user is a single user database running on a personal computer, and multi-user is supports multiple users at the same time. Okay. Okay. When the multi-user database supports a small number of users, okay, for example, less than 50, okay, in an organization, okay, it is called work group database. Okay, so when the database is more than 50 user and usually hundreds, okay, across many departments, it is called enterprise database. Okay, these are the type of database based on location. Okay, location might also be used to classify the database. For example, a database that supports data located in a single site, it is called centralized database. Okay, and a database that supports data distributed across several different sites, it is called uh, distributed. A cloud database is a database that is created and maintained using cloud data services such as Microsoft Azure or Amazon AWS, where they are which is provided by a third-party vendors. Okay. Okay. For type of data stored, basically in some contexts, such as research environments, a popular way of classifying databases is according to the type of data stored in them, right? Okay, basically there are two categories, which is general purpose and discipline specific databases. Okay, general purpose contain wide variety of data used in multiple disciplines. Okay, for example, a database that contains general demographic data, okay, and also the ProQuest databases that contains newspaper, okay, magazine and journal, right? So for discipline specific type, it is contains data that focus on a specific subject areas, okay. So this type of database is used mainly for academic or research purposes, okay. For example, Compute States or CRSP, which is Center for Research Security Prize, okay, and also Geographic Information System, okay. Right. Next is uses of databases, okay. We start with the operational or transactional type of database, which supports a company's day-to-day operations. Okay, analytical basically focus primarily on storing historical data and also business metrics, which is used exclusively for tactical or strategic decision making. Okay, so two main components of analytical databases is data warehouse and also online analytical processing front end. Okay, next is a data warehouse, which stores data in a format optimized for decision support, and it's contain historical data and also structured. The structure is quite different. Okay, the last one is online analytical processing, which is a set of tools that work together to provide an advanced data analysis environment for retrieving, processing, and modeling data from the data warehouse. Okay. Okay, now is the last type of database, which is degree to which the data is structured. Actually, a database can also be classified to reflect the degree to which the data is structured. Okay, we start with the unstructured data, which exists in their original state, which is a raw data state. Okay, um, and structured data which is result from formatting. Okay, and the structure applied based on type of processing to be performed. Okay, semi-structured data have been processed to some extent, and extensible markup language represents data elements in textual format, okay, which is XML databases, which support semi-structured XML data. Okay, okay, this table basically to show you the comparison of the features for several well-known database management system. Okay, you can see Microsoft Access, MS SQL, IBM DB2, as I said earlier, MySQL, Oracle, Dbms. Okay, so this table divided by showing you a type of user, either is single or multi-user. Okay, the data locations, the data usage, and also it contains or present the data in XML. It can present the data in XML or not. Okay, I think you can read this. Okay, why database design is important? Okay, basically database design focus on design of database structure that will be used to store and manage end user data. So designer must identify databases expected use, okay, and different approach needed for different types of databases. Right, well-designed database can facilitate data management and also can generate accurate and valuable information. Okay, so poorly designed database can cause difficult to trace error and also generate error, which leads to bad decision and can lead to failure of organization. Right. Next topic is evolution of file system data processing. Okay. So the reason why you need to know about the file system because the complexity of database design is easier to understand. Okay. And understanding file system problems will helps you to avoid problems with DBMS system. And also knowledge of file system is useful for converting file system to database system. Okay, so manual file system typically composed of a collection of file folders which tag and keep in cabinet. Okay, it is organized by expected use. Okay, so contents of each file folder are logically related, and manual systems will serve as a data repository for small data collections and cumbersome of large collection. Okay, so computerized file system is data processing specialist converted computer file structure from manual system, which can wrote software that manage the data and design the application programs. Okay. Okay. Initially, computer file system resemble manual system, and as the number of file increase, file system evolve, which is each file use its own application program to store, retrieve, and modify data. And each file was owned by individual or department that commissions its creation. Okay. Okay, this figure show you a simple example of a customer data file for a small insurance company. Okay, you can discover that the file structure shown in this figure is typically found in early file systems. Okay, which is considered as unsatisfactory for a database. Okay. Okay, basic file terminology. Okay, basically, the description of computer files requires a specialized vocabulary. Okay, so every discipline develops its own terminology to enable its practitioners to communicate clearly, right? So by using a proper terminology, like showing in this figure, okay, you can easily identify the file components, right? Say, for example, we have a term data, which is a raw facts, such as telephone number, birth date, customer name, and so on and so forth. So, term field used for a character or group of characters, okay, that has a specific meaning, right? So, this field is used to define a store data, okay? So the record is a term used for a logically connected set of one or more fields that describes a person, place, or things, right? So a file term used as a collection of related records. Okay, for example, the file might contain data about students which currently enrolled at gigantic university. Okay, these are the basic file terminology that will be used during the database management systems. Okay, this figure show you an example of a simple file system, okay, which each file in the system use its own application program to store, retrieve, and modify data. And each file was owned by individual or the department. Okay, for example, here we have a sales department and personal department. They have their own files. Okay, files, system files. Okay, for example, here is a sales files and customer file. So each of these files will use its own application to store and retrieve. Okay, and also modify the data. Okay, this is another example agent file. Okay, I think that's all for the part 1 video. See you in a part 2 video for chapter 1. Okay, thank you.